and it is recording now. So again, welcome to the Intro to CompSci screencast of what is going to be on your Java exam. Okay, so first things first, we are going to go over some technical terms. I'm going to go over everything in 45 minutes that is relevant, that will be on your exam. Okay, let's start off with variables. Now you will hear the term primitive. Primitive is because that means that they can only hold one thing. So this is a comment code. I'm going to have this all over the place. So primitive variables. Now, if I'm going too fast, the beautiful thing about technology is that this is a recording. Use your rewind button. Ha! Now, primitive variables. We're going to go over just the most simplistic of details just so you get this. So we have int a. Now, int is an integer variable. It can only hold whole numbers. It cannot hold decimals. So when I am saying int a, this is a statement. Statement and arguments are ended by a semicolon. If you forget to put semicolons in your code, it is an instant half point off, okay, because it means that it will crash. What I have just done right here is an example of declaration. Okay, this is an example of variable declaration. What you are telling the computer is, I declare A to be an integer variable. And what the computer in the background is doing is it is saying, okay, of all the memory that I have on my computer, I'm going to reserve this amount so that when you do use A, you've got enough storage for it. Right now, there is nothing in A. We go to the second step. A equals 32. Now, can it be a negative? Can I do a negative like this, negative 32? Yes, negative and positive numbers are all fair game. They're all good to go. This is an example of initialization. Now, most of the time, you can create a variable in one line. Int b equals 98. This is an example of SLDI. Okay, I'm not going to write it out, but it's basically single line declaration and initialization. I can also make multiple variables on one line. Int c equals 6. And the way I do it is I just separate it by a comma. D equals 98. E equals, or just say E. I'll just say E. What I have done here is I have declared 3 variables. I have only initialized 2. C is an int variable, it's equal to 6. D is an int variable, it's equal to 98. E has been declared. It has no value. So what I can do is later on in my code, I can initialize it, like I have done here. Now we have covered ints. There's also the other variable, double. Double x equals 90.8. All right? It holds decimals. Double y equals 80. Now, the thing that a double does is right here, we've put in 80. And if you saw that, you could be confused because you could say, okay, it's an integer. There's no decimals. But what double does, and when I print it out, let's just say I print out y, prints out 80.0. On the back end, it adds a 0.0 to it. Can I add ints and doubles together? Y plus c. 86. C is equal to 6. Y is equal to 80.0. Absolutely. Perfectly work. Doubles take precedence. What that means is if I were to change this to b and c, b is an int, c is an int, there will be no decimals. But if I changed it to x, it's 96.8. Doubles take precedence. So if you're adding integers or doubles and integers, just know that the double will take precedence. Okay? All right. So now let's go over another variable. Okay, actually, we're not going to go over variable. This is kind of like, we call it a variable, but it's actually an object. And what this is string. Now, string, the reason we call it string an object is because, notice one, that it's capitalized. Two, let's say string name equals Marty. Okay. If I do name and I use something called the dot operator, which is basically just the period, name dot, I get a list of all these methods that will pop up. Now on mine, for some reason, I updated my Eclipse. It doesn't show anymore. But on yours, you'll see all these methods. Okay. There's 76 string methods. You only need to know 6. All right. So the first one that we're going to go over 5 now, and then we'll get back to 1 later. So this one, length, name, I'll put it in a print statement. Sys out name dot length. Now, how do I know something is a method? Because it has open and close parentheses. What goes in those open and close parentheses? Things called parameters. Dot length doesn't have any parameters. So if I run this, it prints 5. That's how, and then what it does, it basically just gives me how many things are in the string. Now it also counts spaces. So M 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Spaces, punctuation, everything is counted. Okay, so system print line name.length. Now, it can be, now the other thing is it spits back an integer. So this int can be stored in a variable as well. I can either print it, or I could say int name size equals name.length. And then I can copy this and I can print out the variable. There it is, 10. Okay. And if I scroll up my console, there we go. There are my numbers, 10 and 10. Okay. So again, dot length spits back an integer. That is important to know. It spits back an integer. Because it spits back an integer, I can either store it in an integer variable, I can use it in a mathematical equation, I can do anything with it that is numerical. The next 2 methods are easy. Upper and lowercase. You can store these in a string, but most of the time you'll just print them out. So I'm going to just do 2 print statements. Name dot to uppercase and name dot what to lowercase. So if I run these, it either gives me everything. I've got Marty time, all in capitals, as it should always be, or Marty lowercase, much smaller, easy to read for garden gnomes. Okay, small people, little font. All right. Now.
Are you included in that?
Nope. All right, so the last 2 that we're going to learn for at least just the time being are substring. So substring, we have 1 and 2 parameters. So substring 1 and 2 parameters. Here's the deal with them, okay? What it does is in Marty time. Now, when we are counting how many letters, when we are counting the length, by default, is we start off with 1, 2, 3, 4, etc. But when we're dealing with something called substring, it's basically like we're using a list of letters that have been combined within quotes. And when we're using those lists, by default, they always start at 0. So the capital M is occupying the 0 index. Now, the lowest index value possible is 0. The highest possible value is always if n is equal to the length of the string n minus 1. So we know when we did the dot length method here, it was 10. What is the highest index value? 9. Very good. So if I said sysout name dot substring, let's say 3, 8. What this will do, or I'm sorry, we'll just say 3. Sorry, we're dealing with one substring. What this does is it prints out ty time. 0 for the m, 1 for the a, r for the 2 for the r, 3 for the t, and it prints everything out. So what one substring is doing is basically saying your string will start at the 3rd index. It is inclusive. It is inclusive. Okay? Now, you also have 2 parameters. Now, what the second parameter does is it changes your ending index. Yes, Danielle.
So why do you need the parentheses in just regular string if you do the parameters in substring only?
What?
Why do you need, you see your parentheses, like 2 uppercase parentheses?
Yes.
Do you need those parentheses?
Because again, the reason, the way that we are able to identify whether something is a method is if it has rules. Parameters are rules. In order to run this specific method, there's no clear-cut rules that we need. But in order to run substring, yeah, it's asking you to put in numbers.
So do you, if let's say you want to print just like t time into uppercase, you could do that.
I could do name.substring38.to uppercase.
So you have to like combine both.
I can combine them, and the reason why that I can combine them, what does substring spit back? A string. Is to uppercase a method of a string? So you can keep going and adding on as long as whatever's being printed out has that method. So if I were to do this now, ty, ti. Ti, ty, ti. Why? Because my starting index is 3. 3, 4, 5, 6, 7. M is the 8th index. But what do we know when it is 2 parameters? It is exclusive of the second one.
You have to
So I'm going to get rid of that first. Huh?
Can you have it change into uppercase and then print it all out at the same time?
Yes. Okay. All right. Does anybody have any questions regarding substring 1 and 2 parameters? Now let's go back. So those are the methods. You will need to know these methods. You will need to know what they do. As you can tell, they're really not that difficult. All right. And you've got the console here. And I'm going to be working my way up. So now what we're going to do is we're going to go back to working with numbers. Okay? Numbers in math. All right? So we have our standard operator. So what I'm going to do right now is I'm going to use a block comment code so that you guys can see this. Plus, minus, multiplication, division, and, oops. Oh, that one's tough. The division, that one's always tough because it's going to be... There we go. Division. Oh, no, I can't do it that way. Block comment. See, it's looking the minute that it saw that. I can't do it that way. Darn it. Okay, so numbers and math. We'll do it like this. The operators. Addition, subtraction, multiplication, division, and not percent sign. This is called modulus or modulus. Either one, modular or modulus, it's fine. This is the remainder, okay? So if I were to say 5 modular 3, it would spit back 2. 5 modular 3, 3 goes into 5 one time with the remainder of 2. It is your remainder operator, okay? What is the rule that I asked you to remember? Yes?
It was if A is smaller than B.
Exactly. So here's the rule for modular. Spits back A. Perfect. Good job. So rule 1 for modular. If A is less than B, it spits back A. So for example, 8 modular 16. Okay. Now, do these actually manipulate the values of variables? No, standard PEMDAS applies. But we do have certain things that do manipulate the values of variables. Those are called compound operators. These ones I will do in block comments. So compound operators actually manipulate the value. So x equals x plus 1. As I told you in algebra, this is illegal. Okay? This is absolutely illegal. Because what happens is you subtract x from both sides, you get 0 is not equal to 1. It's an inequality. But in algebra, or but in Java and other programming languages, this is completely legal. And the way that this is read is the new value of x is equal to whatever the old value is plus 1. So let's say here that I said int x equals 6. Right now, this would be x would equal 7. Okay, and let's go down the line. There are compound operators for all of these. So I can do x minus 1, x equals x minus 1. Now x would be equal to 6. X times equals 1, still equal to 6. X divided by 1 would be 6. And x modular equals 1, or modular 1, x equals x modular 1, would be what? In this case, 0.
Mr. Martinez, has any of the code answers changed? Like you said, they give us those 3 options. Are there still the 3 options that would be?
Not going over that. And I told you I wouldn't review that again. Okay, so these are compound operators. Now, they can also be written like this. Plus equals 1. X minus equals 1.
But it doesn't matter the way you write it.
So okay, it doesn't matter the way that you write it. Okay, hold on. Okay, it doesn't matter. They mean the same thing. Okay. Anybody have any questions? So go take a second and write this down. You need to know these. Again, what compound operators do is they actually change the physical value of variables. All right, now we have compound operators. We've gone over them. Again, when we have our standard plus, minus, addition, subtraction, we're not making any changes. Okay. Oh, the other one that you need to know, in this case, it does the same thing, x plus plus and x minus minus. All it means is add 1, subtract 1. You're not going to get any of the crazy long ones where you're going to have to know all the rules. In this case, it'll mainly be used for for loops. Okay? Okay. Now, we need to go over the scanner class. Okay? So we've covered all the compound operators. We covered this and stuff like that. Let's go over the scanner class. Scanner, KB equals new scanner system.in. When you create the scanner class, what the scanner class is it is a built-in method in Java that allows you to take user input. Here's the problem. Java doesn't trust you enough to let you directly access the scanner class. So what it does is it says make a clone. That way, if we screw up, we can just delete KB. Now, KB can be anything. can be keyboard. A lot of people like to just make it input. It doesn't matter. Whatever in your brain is going to help you realize what user input is, that's just the name of the object. That's the name of what's inheriting everything. I use KB because it's short for keyboard. Some people like to put KB reader, keyboard reader. Okay, whatever works for you. That specific name can be anything. Now we have an anomaly in scanners. We're not going to go over that. Okay, what we're going to do is right now we're just going to cover what the basic methods are. Int a, or let's say int num equals kb.nextInt. Now, this is the method that allows you to accept integers. And the way that it works is it's basically saying once it gets to here, pause the computer. Int num equals, pause the computer. Let the user type something into the console, and the minute they hit enter, resume with the code. Store it in here and keep going. That is what this does. Okay? Now I have double new num equals kb dot, if we had next int, what do you think we have for doubles?
Double.
Next double. This one, it does the exact same thing, the exact same premise. The only difference is this one is capable of holding decimals. Same rules apply. If somebody puts in 40, what gets stored?
40.0.
40.0, very good. String name equals, okay, so, or do we already have name yet? Let's say nombre. We're getting a little bilateral here, okay, or bilingual, whatever. Okay, string nombre equals, now a lot of people think that it's kb.nextString. No. It is kb.next. Now, we also have something called sentence equals,
Maybe on X is what again? Sorry, new string.
so string nombre equals kb.next. And then we also have one called next line. Now let's go over the differences between the two. Dot next only holds one word answers. So for example, what is your first name? What is your last name? Stuff like that. What is your favorite color? Little things like that. Once you put in multi-word answers, like if I said, if I said string city equals kb.next and you typed in Los Angeles or Culver City or West Los Angeles, it crashes. Next doesn't understand how to interpret spaces. Okay? Next line is for that. Next line will hold complete sentences. So for example, if I said, what is your complete address? You could say string addy equals, and a person could write their entire address. Everything. Spaces included, and you'll be fine.
So can you just always use next line?
A lot of people always use next line, that's fine, but again, it's next and next line. Next is for one-word answers. Next line is for sentences, multi-word answers. Yes?
So with that, does that take up more space?
Yes, it does. Next line takes up more space. So even though, our computers are so fast now that we can't even, it's not noticeable to the human eye, if we were to slow it down in layman's terms, the computer would take a little bit longer to run this program. Yes?
Didn't you say we need a new?
We're not going to go over that, okay? No, we're not going to go over the new scanner. I just told you we're not going to go over the new anomaly, okay? Now, so we have scanners. You should know how to use them. Obviously, you ask the user the question first, then the answer. Yes?
Are we going to have to know the import too?
No, okay? But you will have to create a scanner. I'll tell you that right now, okay? And I know what you're thinking. Scanner, I barely know her. But no. Okay, now, logical operators. Oh, God, that was recorded. All right, logical operators. Okay, I will just cut that section out. Okay, so logical operators.
So that means you have to watch this whole thing over again.
No, I don't.
Do you see when we were above?
Okay, so logical operators. Very simple. Less than. Greater than. Less than or equal to. Greater than or equal to. Not equal to. And equal to. So remember, when we're using one equal sign, that is called the assignment operator. When we use two equal signs, because we use one equal sign, we're basically saying something, we're giving something a value. We are assigning value to something. But when we say equals equals, we are doing a comparison. Is something equal to this? Okay, but if you're ever, is A equal to 8? Is name equal to Jonathan? Is password equal to enter 123? Things like that. So you have to think of it this way: equals equals. If I'm ever asking that question, yes.
What does the exclamation point stand for?
Not equal to.
Not equal to.
Okay. We also have by itself. We have the not operator, and the not basically just takes anything that was true or anything that was false and reverses it. It takes the reciprocal. The reciprocal. That is the opposite in mathematical language. Okay.
Dude, now we have that on video.
Well, considering that it's a screencast and you can't see me, no.
Oh, wait, we can't.
Now, we also have and we have or. You need to know the rules for your ands and your ors, the truth table. The only time an and will be true is when? If both sides of the equation are true. Otherwise, 75% of the time it's going to be false. An or, when is the only time an or is going to be false?
If both of them are false.
If both of them are false. Otherwise, you got a 75% chance of it being true. Now, what is it called if the first and is false or the first or is true? There was a term.
If the what?
So, for example, just so we can see this. So let's say that
Conditional?
I have int a equals 7, b equals 8, and I said a is greater than 8 and
That's what you wrote.
b is less than 9. So right off the bat, a is greater than 8. Is a false?
Yeah.
So we want to make sure that both are true. We're always testing to see if they're both true. So if the first one in an and statement is false,
All false. It's all.
it's all false, what is that term called? If this was an or statement, and I said a is less than 8, or b is greater than 9, is a true this time? So in an and statement, if a is false, if the first equation is false, and in an or statement, if the first equation is true, we don't have to check both sides.
Yeah.
That is called short circuiting. Yes, we did.
You're good.
Short circuiting. In a multi-equation statement, if in an and statement, if the first equation is false, in an or statement, if the first equation is true, it's called short circuiting. The reason why in an and statement, if the first one's false, in order for it to be true, they both have to be true. So that first one's false. There's no point in even checking the second one. It's false. In an or statement, either one can be true. So if the first one's true, do we even need to bother checking the second one? No. This is called short circuiting. Okay, makes it it's built in the computer, so it naturally just goes faster. Okay, so these are our logical operators. Now, we use our logical operators with what we call if statements. Okay, I'm going to say int w equals 9, and we're going to say x equals 10.
Wait, which part of that is short circuit? The first or second?
Int w, and let's say r. Because I already used x. Sorry about that. Okay.
Which
In the and statement, this first one's false. In the or statement, this first one's true.
yeah, but which one?
That's the short circuiting. Because in order for this to be true, both have to be true. So because one's false, I don't even need to bother checking the second one. It's going to be false.
So the first statement is called short circuit.
Yes.
The other one, no.
Yes.
The other one is
Okay. Now, int w equals r, or 9, r equals 10. We have these two numbers here. We have learned about something that tests conditions, statements of consequences, if one will. Okay? If statements. If statements rely on conditional expressions, inequalities. So right now we're just going to go over the structure of them. So if W is greater than R, we're going to print out W. Now you'll notice, do I have any errors? I can have an if statement just completely by itself. What if I wanted to test, well, in this case, W is greater than R. If otherwise, what's the only other option?
It's false. And it skips it.
So the way that this works is if this conditional statement is true, it will go into these brackets and it will run all the code there. If this is false, it just skips right to here. Now in this instance, we have three possible values or three possible answers. So we have if, we can say else if. And what else if allows us to do is it allows us to add on and link another conditional expression. Basically look at it like a multiple choice question. This is option A. This is option B. And we can keep adding this. C, D. So if R is greater than W, we're gonna print out R. Now there is a third option. If W isn't greater than R and R isn't greater than W, what is the only other thing they could be? They could be equal to each other. Now in this case, we lock out. Because it's the only other option that it can be, we can use something called the else. The else does not use a conditional statement. Let me repeat that. The else does not use a conditional statement. You have to look at the else like on a multiple choice question, this is option A. If it's not A, test option B. This would be like option E, none of the above. It's what we call our default scenario. So so we would just say equal. So again, this is an if, else, and the if, else, if. Now again, another thing I wanted to show you real quick also, just I'm going to cut this. Notice that I can end on an else if. I can end on an else. Or I could just have the if by itself. Doesn't work with all of them that way. I can't start off with an else if. I can't start off with an else. The other thing is I can't break chain of command. I can't just put a random print statement here. That breaks the linking. They all have to be together.
I mean, they all have to be.
Like they all have to be one after the other after the other. Yes.
So you can basically have an if with the else if, but you with no else.
Correct.
But you can't have.
And I can have an if and an else with no else if. Okay.
But you can't have like an else
By itself, or an else, or start with an else if. It's basically like, let's say I gave you a multiple choice question and I started off at option B. What's A?
So we'll always start at if.
Always. It will always start at if. If you start at else if, keep doing that. I will happily take points off. That's my way of saying don't do that. Okay? All right? How about that? Should have been a singer. All right. Now, the last thing that we are going to cover, actually, we have a couple more things, but the last thing that we're going to cover for this review is the for loop. Okay? Now, I know what you're thinking. Why not the five loop? Not spelled the same. The for loop has 4 parts. Int j equals 0. This is the first step. That step is called the initialization step. Now, this variable is what we call a counter variable. It is going to keep track of our iterations. Iterations are basically how many times we are going to loop. Okay, how many times we cycle through. Step 2, our control expression. J is less than 5. Now, technically, this is step 4, and I'm just writing it ahead of time, because what this does is, and we'll go over, this is technically step 3. So step 1, creating of our counter. Step 2, our conditional control or logical statement. If this is true, is 0 in this case less than 5? Because it is, it comes down into here and it prints out, or it will run whatever code is between these curly brackets, okay? So it says system print line hello. It does it once, then it comes up to step 4, the step expression, where we are either incrementing by 1 or decrementing by 1. We can also increment by 2, 3, multiply. Plus is just easy because it goes 1 by 1. Now J is 1. Is 1 less than 5? Prints hello. Add 1. It's 2. Is 2 less than 5? Add 1. 3. 4. Is 5 less than 5? Once this statement is kaput, it skips to here. And it is done. Okay? Just like the if statement, it relies on the conditional expression. And as long as the conditional expression is true, it will always go into the code and run. Yes.
So it'll print out 4 hellos in a row if you run it. It'll be like,
It'll print out 5. 0, 1, 2, 3, 4.
okay.
Also, okay, so it's initialization, which helps keep track of iterations, and then J is less than 5 is control.
The control, logical, or conditional expression. Okay?
And then the next one is J plus plus.
The step expression. You won't need to know the names for this test. Okay? You will need to know how to read.
The step expression, so step expression, could it be J minus?
Yes, absolutely. Good. Okay.
So
Now,
what would happen if it was J minus 5?
so for example, if I wanted to rewrite this as a minus minus, I would say J is equal to 5. J is greater than 0. J minus minus. So 5,
Okay, 5,
then 4, then 3, then 2, then 1.
You print it?
No, I can't right now because I have my my scanner object. So this will pause the computer. So I don't want to do that just now.
Can you re-explain when you would do J minus minus?
On a countdown, I don't think I'm going to have you do minus minus. I can pretty much tell you right now you are going to need a for loop, and it's going to be a plus plus. Okay?
Is that in the code?
Yes.
That's all.
You will need to write a for loop in this code.
Is that a long code? So this
It's not a long code for me.
this is the
I
for
like
loop
for
right
us.
here.
Yes.
So that would be like what would you have to write the numbers you get?
Yes. The code is probably about 10 to 15 lines long.
What? That's so long.
We're already at 77 lines of code on this review.
Oh, that's still pretty long. No, but this is
How it
not like
Okay?
lines long over?
All right, so that is the review.